My name is Ian.
My name's Jack.
My name is Jonah.
This is our thermodynamic mini project. So a little background on the experiment. This experiment was conducted at Rutgers University. The goal of the experiment was to study the effect of pressure on a behavior of a binary isotrope system. Vapor-liquid equilibrium was established in water and 2-propanol. Some relevant experimental methods. Nitrogen was used to supply the pressure used in the experiment through a Steele reflux condenser. Pressure was controlled with the stainless steel monostat. After equilibrium had been achieved and maintained for 1 hour, the dissolution was stopped suddenly by emitting nitrogen into a system, and the samples were then withdrawn. This is a high-level overview of the system where we have a bunch of the things that they utilized.
In terms of vapor-liquid equilibrium data, so they went into the activity coefficient data and computed that with 2-propanol over a range of pressures from 95 to 3087 millimolar. Once the temperature pressure equilibrium is reached, distillation occurs over 1 hour and distillate is collected. And the activity coefficient equations and sample data set that they use is seen below. So on the left, the equations, and the right, sample data set. In terms of consistency, they decided to validate with other equations of state. And so they used the method of Carlson and Colburn to compare 2-propanol and water with the graph, as you can see to the right. And they used the simplified Van Laar equations that are shown below as well. In terms of Redlich-Keisler's equation of state, they made a comparison to that as well. In terms of that, they use the graph you can see to the right. That's this thermodynamic consistency, along with adjustable parameters of B, C, and D, as you can see down in the equations below that kind of validate their process.
So the effect on azeotropic behavior that came from a conclusion of this experiment was that as pressure increased, so did the azeotropic boiling point and mole fraction of 2-propanol, which you can see in table 4. The change in composition, however, was too small to be represented by any empirical relationships between azeotropic composition and pressure. Some of the equations that we learned in Thermo 2 that apply to this experiment are the azeotrope definition, the Van Laar equations, and Rao's law for azeotropes. And in conclusion, the calculated data from the Redlich-Kwon's equation of state is supported by the experimental data obtained in this experiment. The results of this experiment show that as pressure increases for an azeotrope, so do the boiling point and mole fraction. And using the relationships proposed by Lichten-Dessler and by Othmer, you can extrapolate the effect of pressure on the boiling point of the azeotrope. This method for Othmer is limited to the range of a reference vapor pressure that exists, though. And this is cool because we can use this to verify where the relationships and thermochemical data actually comes from. And then these are our sources.
Thank you.